When we're solving equations in these new trig functions, the best way to do it is to put them back into the ones we're familiar with. So as in back into tan, sine, or cos. So if we look at this first one, sec theta equals 3. So we don't have a function on our calculator that says sec theta. So what we need to do is put that back into cos theta. So since sec theta is 1 over cos theta, then we've got 1 over cos theta equals 3. And if we rearrange that, 1 equals 3 cos theta, and then cos theta equals 1/3, which if we make sure we're in degrees mode on the calculator, because the range is given in degrees, it doesn't always specify in the question whether we want the answer in degrees or radians, but it's implied by the way the range is given. So from this, theta, our working angle, is given by cos minus 1 of 1/3. And from that, the calculator will give us 70.5 if we do it to 1 decimal place, 70.5 degrees. And of course, we need all the values in that range up to 360. So if we look at the cos graph, then that looks like that. So there's our 70.5, and because it's symmetrical, about 180, we can get the other value in our range, this one here, by taking the 70.5 away from 360. So we also get theta is also equal to 360 minus 70.5, which gives us 289.5 degrees. So there are two values in the range required. Again, if we look at this one, look at B, it's a similar process. So what we're going to say is, well, cosec theta is equal to 4. We're now going to write it in terms of either sine, cos, or tan. And so cosec is equal to 1 over sine theta. And so 1 over sine theta is equal to 4. From that, 1 is equal to 4 sine theta, and sine theta is equal to 1/4. So we're going to then find theta, find our working angle. So theta is equal to sine minus 1 of 1/4. So if we then find that value, the calculator will give us 14.48. And because we're looking for values in a range, we need to draw the graph again. And so sine graph looks like this. 0, 180, 360. Value our calculator's given us is this one, 14.48. But in our range, we've got another solution, which is here. And by symmetry, this solution is 180 minus 14.48, which is equal to 165.52. Now look at this one, which involves cot. Then what we can say is, if we replace the cot by tan in this case, we've got 1 minus 2 over tan theta, and that's equal to 0. So I'm going to take the minus 2 over tan theta over to the other side, and I'll actually end up with 2 over tan theta equals 1. From that, tan theta, multiply both sides by tan theta, is equal to 2. So then I need to find theta, the working angle. So that's going to be tan minus 1 left 2. Looking at the range, I know I must be in radians now because it's implied by the range being in terms of pi. So if I use a calculator set to radians, I'm going to get 1.11 radians. And then if we look at the graph of a tan graph, then what we've got is we've got asymptotes at pi by 2 and also 3 pi by 2. And this is our range. So draw the asymptotes on and our graph will look like this in our range, going through 0 at 0 degrees, pi degrees, or pi radians I should say, and 2 pi radians. So it looks like that. So the solution that we've been given is for tan theta is 2, and the calculator gives us this value, 1.11. And because tan repeats over pi radians, we can find all other values just by adding pi radians to our first value. So the next one would be 1.11 plus pi, so that will give us 4.25 radians. So these are our two solutions. If we now look at D, so we've got cosec squared theta equals 4. So again, we're going to write the cosec in terms of sine. So that's going to mean cosec squared is actually 1 over sine squared. So we can say that's 1 over sine squared theta equals 4. And so if we rearrange that, we can get 1 is equal to 4 sine squared theta. And then divide by 4, we get sine squared theta equals a quarter. Take the square root. And what we'll get is sine theta is actually equal to, because positive and a negative root, plus or minus a half. So if we find, first of all, the positive root, we've got that theta sine minus 1 of a half. And we should be getting familiar with that one. We're working in degrees. Sine minus 1 of a half is actually 30 degrees. And for the other one, sine minus 1 of minus a half will give us minus 30. Okay, so I'm just running out of space here. We'll do it over here. I'm just going to draw the sine graph. Now we're interested in the range 0 to 180. And so that's actually just this portion, because there's 180. And looking at the negative one, first of all, so that would be there, minus 30, and that's minus a half. We can actually see that in the range 0 to 180, the sine graph never actually goes negative. So we can reject this one because there are no solutions in the range. However, for the positive one, we've got 30 degrees, and we can see that because this is symmetrical, we can also subtract 30 from 180 because this will also be 30 degree in distance, and that's going to be 150. So our solutions are actually 30 and 150. So for this one, we've got theta is 30 and 150. But again, the main principle of these is just to change them into either sine theta, cos theta, or tan theta.